So this is Bill Bittner. We're continuing with the VM workshop. This afternoon we have Barton Robinson and Rick Barlow from Velocity Software that are going to share with us about what's new in their space. So Barton, over to you.
Thank you, Bill. So I'm going to take a few minutes just to talk about 2020 and what we've been doing, and then talk about our middle to cloud experience, which to me it was just pretty exciting. So I'll talk a little bit about that. So I'll talk about what we did. 2020 is, if you sit back and reflect, which we've had a chance to do, 2020 has been pretty interesting so far. I'm going to talk about our version 5 and how we've really expanded our support for Z. Talk about Z15 compression and some of the stuff that we've been doing and some of the stuff I just did this morning just for fun. And then I'll talk to the middle to cloud. And yeah, we really we had a brand new box from IBM, and in 2 days it was up and running and we were cloning servers. So a real cloud implementation. And I'll let Rick take over at that point and talk about how we did it. So yeah, 2020. We put out version 5. There's something for almost everybody in version 5. So that was a big job for us. That was a big, long project, and there's just a lot in there. I'll talk about that. It was nice to go to Share and actually see people. My last conference this year was the middle of March, and I think it was the last conference anyone did anywhere in the world, but it was CMG in Cologne, Germany. It was fun to see people. And then we got locked down. So right after lockdown, we entered into the IBM ESP for the Z15 TO2. So imagine moving your full data center from California to Ohio in the middle of a full lockdown. But it was very enjoyable. We got it all done. And I don't think anyone really noticed that we did it, especially since we couldn't talk about it. So one of the projects as part of this, as soon as we got the code 20 from IBM, we said, all right, what does it take to create a full cloud in 2 days? Because you keep hearing, Z's complicated, it's hard, takes a long time, you need all these special skills. I said, all right, what can we really do? So we did that project. One of the websites that we actually host on our VM system is the vmworkshop.org. So in the middle of all your workshop planning, that website actually got moved to Ohio, and I don't think anybody noticed, along with velocitysoftware.com and a whole bunch of other websites got moved. And so it's pretty much we did it without anyone knowing we did it. That was pretty cool. We moved all our development. Yeah, the box is a lot faster. It's really cool. So everything goes faster. And we moved our Linux servers, and this week we're turning off our old BC12. Yay! So version 5, yeah, is pretty big, and there really is something for everybody. And by the way, we do support up to 96 CPUs, so whatever comes out in 7.2 or the next release after that, I think we're pretty much ready. But yeah, so pretty much all of VM is supported. We added a lot of subsystem support. I mean, if you look at the Marriott story for Mongo, if you look at the installations using Docker, we put in a lot for Docker. A lot of the banks are asking for GPFS support. Let's put that in. So that was kind of, for us, was business as usual. But then we started adding other things. So we had several requests to do ZOS, and finally we came up with something for ZOS. So it just fits right into our standard architecture. We ship the SMF records over from ZOS. I know this is not a big ZOS crowd, but most of you do have ZOS in there somewhere. We have the most efficient, I always say we have the most efficient processing of the CP monitor facility of anybody. We definitely have the most efficient SMF processing of anybody too. So we ship the SMF records over from ZOS or to VM, and it just is business as usual for us, which means we get to use all of our graphics capability, all of our front-end capability, all of our database capability. And then at the last conference in Germany in November, the VM VSE conference, we announced VSEmon. And it's just a no-charge feature of zVPS. And if you want more details on that, Rich is going to be talking about it on Friday afternoon. But really what we're looking at is we've been doing VSE for 10 years. We've added our own MIB. And then when we did the kicks for ZOS, we looked at it and says, you know what, we can do that for VSE too. And then we talked to Jeff Barnard, and we said, okay, what can we do for the BSI stack? So we implemented that. And we're working with CSI on their stack as well. So that means that we've really added an awful lot for VSE, and we can do full-time, real-time monitoring, we can do post-processing, we can do the chargeback capacity planning for the VSE environments. So that was kind of cool, and we're pretty excited about doing that all support. And then my good friend Wilhelm, I was seeing a presentation by him about a year ago, and said, so if you have a performance problem in this really secure facility, what do you do? And he, with a straight face, actually said, well, you take a dump and send it off to Poughkeepsie. And I kind of looked at that and said, well, maybe there's another option. So I did work with the folks in Poughkeepsie, and we do have a performance option for the secure container facility, in that it can send data to zVPS, and we can do all the performance monitoring, and it's all in a legal, secure infrastructure. So we don't break any rules by doing that. So if you look at, management says what they want: a single pane of glass. You want one tool that does everything. Of course, you want it to do everything really well. If you look at what our history, the VM, we've been doing VM for 32 years now. And I think we do a really good job of VM with all the subsystems. We added Linux, and when Linux came out, worked with the Berkeley lab actually on how to do performance monitoring on Linux. I think we do a really good job there. We took that down to the process level and the application level. We had a TCP/IP network monitor. So pretty much, those four: the VM, the Linux, the applications, and the network monitor, that's all part of zVPS, and that's been there quite a while. So, in this release, we've added the VSE and the networking for VSE. So I think we've done a pretty good job for VSE and ZOS. And there's a lot to do in ZOS, but we've done an awful lot already. And people are really looking at that as a tremendous amount of savings in terms of the MSUs, just in the overall dollar savings. So, talk about the applications. We've had Java and WebSphere for a while. We've had Oracle for a long time. So we've added Mongo and the Docker. And also we've had a lot for outside of Z. All your distributed servers, KVM support, the secure container support, Microsoft. We want our VPNs. So that's pretty much version 5, and we've added an awful lot, and I think it's pretty exciting for us just to see how people are taking advantage of it. So with our Z15, one of the things I looked at is just the whole compression. What can we do with that? Since we're shipping a tremendous amount of data from ZOS to VM, so that was my first thought: is, well, what do we do with this compression? So one of my developers went through the 42 pages of documentation on that new instruction, and he implemented compression on CMS and ZOS. He can do it for VSE too, but he says, well, there's not very many VSE installations that have a Z15 yet. So, but when we get there, we will. So the compression we're getting for the SMF data is about 90%. But that's only part of what we're seeing. He did create a compression decompression pipe stage. So I was using that this morning just to do some experiments. If I compare the compression on the Z15 with that new instruction against CMS PAC, we all use CMS PAC in a VM environment. I was just looking at our history data, and if I use the Z15 compression, I get about a 75% compression on very dense with data, and with that, in comparison to the CMS PAC, it's about 50% better. So it is really cool, and the CPU requirements is pretty amazing. So this is a ZOS batch analysis. And if you look at the bottom, so we have 3 agents running here. One agent sends the SMF data to VM2, one sends it to VM4, and one sends it to TK. So you can look at the CPU percent, so 0.3%, and that's on a AO2 engine, so that's not very much CPU. So you can't really see the difference in the compression, but one thing we noticed is if you just look at the service units where we get the multiple significant figures, using the compression actually dropped our CPU for the data transmission. So not only are we transmitting the data, we're compressing it, sending a whole lot less data, and we're getting less CPU just on the on that agent technology. So pretty happy with that. So when you look at zVPS, we've had this for quite a while. We have a full enterprise view. There's different buttons you can click. You can click on VSE. Now you'll be able to click on ZOS. You can click on Linux. We want to be able to make this really simple, really easy. So if you click on a Linux, you get a full Linux display. Just we call it one click. So one click, you get everything there is to know about a Linux server. And then each one of these, you can dive into the file systems, you can dive into the process table, you can dive into the active processes. So it's just a one click and into a tailorable screen. So now we look at it as now we have a whole bunch of other data sources all going into zVPS. So now we collect the SMF data, we collect the VSE DMF data, we collect the secure container data, which is actually collect D is the implementation there. And it just goes into our network data collector running on VM. And now we can do a one click and we see ZOS. We can do a one click and we see VSE. So, and yes, I am going through this little quick. There's a ton of material in there, but I wanted to get to what we did with our middle to cloud, which to me is pretty exciting. So, so there's a lot of things on the Z15 that we really wanted to explore and wanted to move our data center out of California for a lot of reasons. So we have this new data center with a Z15. It just opened up, and Rick will show you pictures and talk about what he did there. But it's we all love it. It's really fast, it's small, and it's pretty cool. Plus, it gives us a lot of chance to play. So with our cloud hardware to cloud project, we use ZPRO. And really the idea was, there's a lot of complexity. VM is a really simple, elegant solution. And we like simple and elegant. When people talk to me about what do I want, simple and elegant is a really good approach to almost everything. So ZPRO is our cloud enablement. It provides the on-prem clouds environment. It does it very, very well. Yet it's very simple, and I mean, I like it's simple and elegant. It provides directory management, but there's a lot of things in there. So our objective is to just modernize the platform, keep it simple. Most of all, it's like if you look at the current world around us, they're selling cloud. Well, you know what? On-prem cloud, you can do it really inexpensively if you know how to do it. We're also looking at how do we provide just simple to use management tools. And if you look at our one-click solutions or the way we do it with ZView or enterprise management solutions, a lot of it is it's simple to use management tools. So we really focus on the whole simple. So with the middle to cloud project, yeah, you need some planning, but you think, okay, so we get the code 20, what do we do? Well, format disks. We install a 4-way single system image. We install RACF. I got to say, when we looked at where we spent a lot of time, RACF was not pretty. So if I had to say that there's one thing that really could be improved, it was the RACF. But we really need RACF. Security to us is extremely important. We want to make sure that our cloud is secure. We installed zVPS just so we had all the management tools and the web servers. Installed ZPRO, and we use ZDirect. Just ZDirect installs really fast. And then create a golden image for Linux. And then just to see what we could do, had 155 images cloned in 20 minutes. So that is a full cloud solution. It does not take too long. It's very simple. If you want details on ZPRO, there's a presentation on Friday morning. But this whole thing, it's not rocket science, and I do know rocket scientists. It's very, very simple. So just simple and elegant. So if you look at CMS, it is a very powerful programming environment. Our web servers run native in the CMS. Everything we do runs in native CMS. Having the web server it's very fast. It's written in assembler. It's been there. The velocitysoftware.com website runs on our web server on VM. The Linux VM.org website runs on the VMworkshop.org website runs. So we have a lot of web servers running, public web servers running on our website. It installs in minutes, so it's very, 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 very simple. And we converted to using the IBM SSL. We used to have our own SSL, and it's just a whole lot easier to let IBM do that. So then you look at ZPRO, installs in minutes. And the fact that it installs so fast, I mean, how can you do it? We don't use SMAPI. I look at SMAPI, and we've tried using it. It's way too complex. It's way too error prone. There's just logistics just are not useful to this environment. We do not have a Linux server requirement. So we do all this without having any Linux to run an HTTP server or put logic in there. Java is another one. Had some bad experiences with Java. With the browser issues and the complexity and just the overhead. So, and even Dermate. So we'll support Dermate, but ZDirect is really simple, installs in minutes. The most important thing is it's totally non-intrusive. That means that you can run it side by side with almost any other solution. We support RACF Dermate environments. We support VM Secure. We support LDAP. If you don't have a directory manager, we provide that. And there's no extra servers to put in. Just once our zVPS is installed, you're good. So ZDirect, it's non-intrusive. It doesn't take control of the directory. It will update the directory. So there's some one little thing you have to do with maint, so that if you log on with maint, you don't have dedicated rewrite access to the directory disk. And there's no Linux servers, so you can try it. If you like it, you keep it. If you remove it, there's no pain when you remove it. You just turn it off. So totally non-intrusive, and I think that's really important in today's world where you want to try something. So, all right. So Bill, if you turn it over to Rick for how we did it.
Okay, so I'm not going to spend a ton of time on this. We don't have a lot of time left, but I'll give you sort of the quick version of what we did. Barton mentioned most of these things. I'll go in a little more detail. Planning, implementation, results. Key to any project, obviously. Planning is critical. You got to know what you're doing before you start it. Otherwise, you're just going to spend a lot of time starting and running into issues and restarting. So, from a hardware perspective, Barton mentioned this was a brand new data center, brand new hardware, and a significant upgrade for the Velocity team. So physical site, we're in a brand new data center. So that had its own uniqueness. I've never set up a data center from scratch. So there were some interesting things related to that. We found some really good people to work with. You got to know what hardware you're going to put in there. We chose this Z15T02, got in on the ESP. Wonderful experience. The DS8910F isn't brand new, but it's fairly new. And then, of course, you're going to have some kind of connectivity, miscellaneous routers, switches, etc. Otherwise, you can't talk to the outside world. You got to plan for things like the numbers and types of I/O cards. The Z planning makes that really easy. A few cables. We have all of 5 FICON cables on our machine, so it's really simple, and you'll see a picture in a few minutes. Purchase and shipping. Being an ESP, that added a little bit of complexity, and you have to know enough to do a little bit of definitions. You got to define your LPARs. How many you're going to need, and what are they going to look like? And sometime in the future, I'll probably do a more complete presentation and show you a little more of that. Martin mentioned this, and others have. You got to watch out for the unplanned. We did this in the middle of lockdown, so it was really fun to do some of this stuff. Try and do some of it remotely, and then of course, as we had to actually go on site to the data center to do the work, there were some added restrictions on that. From a software standpoint, you've got to have an I/O cabling plan. You're going to probably use IBM's chiplet mapping tool. Depends how complex your I/O configuration is, and you got to have a starter IOCP. If you don't, it won't talk to anything else. So some basic software stuff. If you've ever worked with a new machine, you're always going to look at things like the driver exception letter and the installation buckets called the PSP buckets, preventive service planning, I believe. And that's actually the name of the buckets. We went through all that to make sure that we had all the support on the system for this new hardware that was that we had never had before. Sometimes that's more complicated than others. It depends a lot how far you are into a release cycle. We were more than halfway into this ZVM 7.1 release cycle, so there was a lot of reach ahead maintenance that we wanted to pick up. And you want to install all that software support before you try and migrate. It's not something you want to do while you're moving from one place to another. And then there's some VM specific configuration information. So the system config file has to know about your new processor and what LPARs you're defining. System net ID also, if you're going to communicate among your LPARs. And then you're going to probably want to define some kind of vSwitches so that your Linux servers and other virtual machines can talk to the outside world. So those are the kinds of things that I did in the planning cycle so that I had all that information ready so that when we went to execute, we could get through it as quickly as possible. So installing the hardware, there's actually a few pictures here. The first picture there is we had some miscellaneous stuff. We needed a rack to be able to put the DS8910 in, and we needed a shelf because we have some other miscellaneous servers that were going to go in there, and just a place to work. So that is an empty rack, the first thing we put in our data center. The first piece of hardware that arrived was a Z15. It took a grand total of about 4 hours to uncrate it, roll it into place, set it on the floor, the few connections that IBM has to make, and power the thing up. And we had that all done in one day. But unfortunately, sometimes things do happen that require some time to resolve. And especially in an ESP situation, it doesn't always work exactly the way you'd hope. And the only reason I bring this up is because we were a part of the ESP, you have access to the lab people, you get excellent response. And one of the things ESP customers, not unlike the sponsor user customers can do, we get to put a lot of input, help improve the process. So we did actually have a problem with the machine when it arrived. Turned out to be a one-off. A bolt wasn't tightened before it got shipped. That caused a problem when we powered up the machine. Not a big deal. It was resolved, but it did take us a little time. So no matter what kind of hardware you're putting on the floor, those kinds of things can happen. So it's just something to be aware of. But that was all, before we really started the clock for the actual software install. So just one of those things to be aware of. And for those of you who like selfies with your machines, that's me and my Z. It was, you always go to conferences and you see people taking selfies with the new machines. And I thought, well, I'm going to have my own. So then the DS8910 arrived about 2 days later. We started on a Monday morning, I believe, to install. What that first picture on the top left shows you is a pallet full of stuff that arrived. All those boxes nicely packed. IBM obviously has some incredible packaging engineers. For example, the box on the lower left, if you can read the label, it says empty box. The crate actually comes shipped square, and part of what it had was intentionally blank boxes. I thought that was funny. But on the right, then you see the actual DS8910. It takes about a half of that single 19-inch rack for all of its components. And after it was about a 6 to 7 hour install to assemble all the pieces in that rack and powered up, and it was ready to roll. So another really easy hardware install. So what don't we have in our data center? We don't have a lot of racks. We don't have a lot of network switches for SAN and lots of Ethernet connections into lots of server, either individual units or rack units. So we have, and it takes very little space. The right-hand picture there is actually everything we have in our data center today, including a workspace. And you can, if you look closely in the far left you can see somebody else's data center. We probably should have taken a picture of some of the cages around us with just the myriad of data. But remember, this is a single drawer, single processor TO2, or single processor drawer TO2, and it's only half populated. And so, in that same footprint, we could be running, just an army of virtual servers. So keep that in mind when you think about complexity of building a cloud. This is definitely the easy way to go. So what did we do? It took us under 18 hours total. We built a 4-member cluster. The VM install does almost all of the work for you. It took about 5 hours, and some of that time was just because everything was reading off a USB stick in the hardware management console, because once again, this is a bare metal system. We didn't have anywhere to start. RACF was a challenge. Barton mentioned that. The dock is in multiple places, and I wasn't as prepared as I should have been, but we got through it. The ZVM service, this is another place we spent about 2 hours, because when you ship ZVM 7.1, you still get the original core, and the RSU, and we wanted to have the current RSU and all of the reach ahead. So building a VM cluster from nothing, I had to install all that maintenance. The Velocity Suite took just a little over 4 hours to install the installer, first of all, ZVWS, ZPRO, that got us the cloud part, and then all of the rest of the performance management components. And it took us a couple hours to stand up a Linux image to be able to clone. Your experience may vary depending on how good you are at doing your Linux installs, but that's all it took us, about 18 hours. And here's just for reference, a Gantt chart. This is actually as close to realistic as I could create to represent what we did. And you'll see there is even a couple of gaps in there. Some other things had to be done along the way, which caused us to basically pause our installation and resume. But the only big places is, as you can see about the 4th line down there, is the VM install itself. RACF on the beginning of the 2nd day, that was a large chunk of time. And then the other big piece was, well, sizable compared to the other components, was getting all of the Velocity software components installed and configured and ready to run. So the results, the thing is fast. We came from a BC12 to a Z15, 3 generations newer. Each one has, the 20 to 30% improvement in processor. Wonderful. Barton mentioned the on-chip compression. I wrote it down as 80%. In some cases, we got as much as 90% reduction there. The other components, we don't have any Crypto Express in our environment. System Recovery Boost, I didn't have time to test. I hope to get through that. The 8910F is super fast. It's all solid state, and you won't see a lot of spinning disks anymore. It's full of all the features. We love using flash copy. It makes the cloning really fast. And I mentioned before the early ship program. I've done lots of them over the years. This one was relatively simple comparatively. The Z15 is a wonderful piece of hardware. Working with the IBM labs and the people who run those programs is a great experience. So if you ever have a chance, I encourage you to do that. And one of the benefits to us was having this new hardware only slightly before GA, which gives you the ability to take advantage of some of those new features, such as the data compression. And that's all I have. If you have any questions, I'd be happy to try and answer.
Rick, can you talk a little bit about the RACF issues?
Sure, I'd be happy to. RACF, while it comes shipped with ZVM, it's not fully integrated. So in order to get it installed, you have to have part of the program directory. You have to have the, I forget what the name of the document is. It's an installation document that comes with it. Some of the instructions are in the ZVM install, but ZVM install refers you to the program directory. It refers you to the memo to users. That's the right document. So you just have to do that. The problem was I didn't have all those documents kind of gathered together and ready to use. So it was really my own mistake that caused some of the delay. I could have done better had I been fully prepared. Once again, that planning cycle in the beginning is extremely important.
Okay,
So-
well, Barton and Rick, thank you all very much. Quite impressive here. I felt good that I cleaned down half a closet and you guys moved the whole data center. Kudos to you all.
So, Rick,
Yes.
so why, it sounds like you built brand new VM images. Why didn't you shift what you had from California?
Okay, so I didn't have all the details in the charts. We actually built a vanilla brand new system with 4-member SSI to just prove that we could do that in a short window. So
Okay.
we hear, as Barton mentioned, you hear all the time, VM's too hard, it's too much different, you have to know too many unique ZVM skills. What we wanted to demonstrate was that if you follow the instructions that are available to anybody, you can actually build this from the bare metal to a fully functional machine in just that 2 days. So that was essentially an experiment. Then we did actually migrate all of the systems from the existing data center in California to Ohio as well. So we just did that outside of this metal to cloud demonstration. So it was actually a 2-phased migration. Does that make sense?
Yeah. Okay. Thank you.
Yeah, the transparency of moving, the other things, Barton touched on that a little bit. We moved our systems. We had another small SSI in California. We moved that over one weekend, and we moved the other 3 production systems overnight on a couple. I think it was all one overnight. I don't have the note right here in front of me, but essentially we brought up a copy of the other 3 systems and then just cut over the network. So that was even easier than the zero to cloud. It was basic. The only delay is we did all of the disk migration using VM to VM pipe DDR basically to get all of that data. We had about 6 terabytes active in on the old system, and that's fairly slow over a single network connection. You can make that all easier with a number of different hardware solutions, but we did that all via software.
Okay, thank you all very much.